from Romania, from your favorite artist electronics here, Mr. Q12. And yeah, I have a project. Actually, this is the project that is here, this board. I made a copy here on the other side of the board, just to look on how the wiring are made. And I'm looking on the screen from my other table in my back when I'm working. And this is the user interface here with the wiring, but I have it without the wiring. And this is the actual user interface. This is how it will look in the end. These are SMD LEDs, 1206. Yeah, that's the interface. But until there, until that stage, I will have to do this. Actually, I have these are all the components. Originally, I built this, but I built this board after I made it in reality. I actually looked in reality and I used what I did there in reality, and I reproduce it here in 3D, just as a sample to have it here. And as you can see, the pin configuration, the outputs are with the 10 kilo here, and this is 7486. But now I'm using 4030, which is having different outputs. As you can see, it's a bit different from that, but only the outputs and the inputs are different. As you can see, and only the outputs and the inputs. The rest is quite really the same function of the chip. I was a little bit worried, but I asked my friends from England, and they told me that it's fine. And yeah, I built actually a couple of models. So on how it all, come on, as you can see here, they appeared. So originally I built it like this, with 74, original with 7486. It remained like this, but then I changed my mind and I used 4030. But so this was the original idea to make it like a little box like this. But I have a ton of space inside here that is unused, and I didn't like it. Then the second version, I put the panel down like this. And I said, well, this is interesting. This is interesting because the wiring, it will be easy to wire everything. So if I'm moving the panel, the wiring will be a bit more easier to do than in my case, like I'm having right now here. And it's a jungle what I'm having here, and it's a problem. And I wish I can do it like I'm planning, because these are two. So it's a bit of discussion here, a little bit, not that much. So if I'm moving this board from here, you see there are two boards actually. One board here with the 4030, and one board here with all these transistors on it. You see, and between these two boards, so if I'm dragging it up, pretty much all this wiring theoretically should be between these boards on their backs, and I have no idea how to do it. And it's a challenge. It's a very big challenge for me to do it this way with all the wiring in their back. Right here I'm showing the wiring on the top of the boards to be able to see everything, of course, and to be able to understand what is what and where it's going, and the logic of it. But all the wiring, theoretically, this is my original idea. I will see if I can actually do it. If I cannot do it, then I will make it on the surface, and that's it. So I actually put a note here. All this wiring will be sandwiched between these two boards, not on the surfaces. And that's my wish. I hope I can be able to actually implement it between the boards. And the boards themselves will look very clean. Only the pads with the transistors and the rails and this data pads that I'm having there, and also here as well on its back, as you can see, I put also not all this wiring will be on the back of this board, not here on the surface. So that's the plan. This is the model that I'm having here. This is the history of it. And let me put it back, hide section. And yeah, I really like. So this will be. Let me actually make a little like this. So this will be like this. This will open like this. So it will have the, you see, on the top here are all these pads, and here on the top are also all these pads. And between these pads, I didn't put it here, I didn't draw it, but it will be wires that are flexed, like a letter C. So let me actually paint it for you. Let me actually change the angle a little bit. So from each pad to its corresponding pad on this side, so on this side here, it will be these wires like this, bent. And then I will close like a lid all this board. I will close it down on top of all of this, and it will be sandwiched. Everything, it will be sandwiched. So pretty much, let me change it. There you go. Affect pivot only. Well, not that one, not everything. So somewhere there. Okay. So this is how it will, it will close. Let me bring it up like that. So this is how it will be open, and this is how I will close it. And on top of it, I will have all the LEDs and everything else. And it will be very extremely compact, and it will look very professional, I may add, like this. And it's very cool design, but unfortunately, it's very hard to do. And when I'm looking inside, wow, holy fuck, what I have there! And the wiring is a very big problem, and I have no idea how to actually implement it. If I will be able to implement all this wiring, oh yeah, and especially if I can implement them between these two boards like I'm planning. I have no idea, but we will see. So for now, I hope you understand what I did here, and let me undo back. This is my presentation. This is what I wanted to show you. I wanted to show you the 3D version that I made first, and then I'm looking, literally, I'm looking back to it with my whole body. I'm turning back and with my head, and I'm checking the placement of everything, and step by step, one by one, little by little, and I'm adding the components, and I'm adding the tracks and the pads, the rails, and everything. Thank you very much for watching, and wish me luck. All right, so pretty much the plan is to use this board that I already made and make 4 probes instead of 1. So right now it's only 1 probe. It is logic probe. It is probing if it's 1, if it's 0, or if it's floating. It's having 3 stages pretty much. And I will transform this, is the same, exactly the same circuit that I'm having there, into a multiple thing with 4 probes. So this is the clean board that actually helped me a lot to, and also that one. So all these 3 boards, these are the clean boards. They help me a lot to visualize where the wires are starting and where they are going. And this is the real board, which is a mess. But making abstraction of the mess itself, it is looking very clean in reality. But here in 3D space is looking like crazy, like crazy. I also modeled this pad that previously I didn't have it, you see. And as in reality, I actually take the dimensions in reality. I measure it. Every pin, the distance between the pins. Yeah, the placement of these wires are underneath here exactly as in reality. But the other wires that I'm having here are purely demonstrative to, like I said, to show what is what and where is where, and where is going from where. Okay, so that's the idea of this project. So I took a very simple project, a very simple circuit, very simple circuit, and I transform it into a bit more complex device that is measuring independently for channels. Pretty much, it's having 4 channels, and for each channel is measuring whatever signal is there on that particular channel. Pretty much that's the project. That was the idea, and it is my idea. I'm only asking my friends from England mostly, because the Americans don't want complications like I'm making. They don't like it. They avoid me. They like clean and simple and easy, not complicated. And if I'm asking something to my friends, is usually to verify and to verify too. The usual problems that that I'm not really aware of those usual problems, like the pin configuration, stuff like very usual, that I am not personally not extremely good at. But other than that, the design, the desire of doing this kind of projects are all mine, not their ideas. These are Romanian ideas. all right. I hope you like my ideas. Shit. Hi, hello from Romania, from your favorite artist electronics, Mr. Q12. Here I have this stage that I am right now. I just built these 2 boards with these 2 components on them, and here I'm using 4030. Yeah, 4030, and before I used 7486, and this is the same XOR gate chip. It's having 4 gates in it, and I'm using them all 4, and not leaving anything. And these are the transistors, PNPs and NPNs, line. This cardboard is very interesting. It's a special cardboard from a cell phone, and I put it aside, and I was telling myself I will use it someday, and today is its day. And black on black, it's a very interesting contrast. It's interesting. I like it, and it's a special challenge. This circuit that I'm making right now. So the components themselves are already done. Not really. I have to include the resistors, but placing the components, it's just not a challenge. It's no problem. The biggest problem that I have, and I will have to deal with it and find a way, are the wiring. And the wiring, it's a very big problem. Why? Because I plan. It's a crazy project. It's a very crazy project. I plan to make it like this, one on top of the other, you see, and when exactly like I'm holding it right now, in this position and in this configuration. And you see, and this is the black one is a little bit smaller because I forget some things. I'm looking back on my monitor, which is behind me, and I'm checking there how the placement of all the components and pads are. And like I said, the biggest challenge will be the wiring, because between these 2 boards on their back, I plan to put all the wiring. I hope I will be able to do it. If not, then I will do it like usual way, putting some holes and dragging all over the place the wires. And the same here. I'm not sure how I will actually manage to make the wiring between these cardboards on their back, to this back and to this back, and only getting out the necessary or the proper wire that will be connected on its place, pretty much. It will be a very big challenge. I have no idea how to do it, and it's mind-blowing, hard. It's extremely hard to do it. I never do it. I never did it. But if I will find a solution, I will certainly show it. And wish me luck. Bye. So this is how I glued everything, and so everything is glued right now and soldered. These resistors are soldered, and I have an idea. I stayed I stay and think, because this is a very, very, very interesting challenge for me. And if I want a certain design to look a certain way, I have to make some compromises. Meaning that so the idea, what I'm planning, is to put these two back to back like this, and to have them like this, and not that much wiring showing on the surface of them, both of them, neither here, neither here. The wiring from this chip that is going to this board and to one of the pads, because it will be 3 pads there. And to actually, oh yeah, motherfucker. And to actually to be able to pull it off, to make it happen, I was thinking in ways and ways of doing it, and I was always thinking on very short wiring, and possibly these boards glue together in 1 or 2 points, and then the wiring I made already the holes. You can see the holes through the cardboard. You can see them here on the other side. If yeah, you see. So the holes are made, and I was thinking to actually insert the wire to the hole while these two cardboards are back to back somehow, and somehow to drive that wire that is between them, and to make some holes in this cardboard as well. I didn't do it now, but I was thinking how to proceed, and move the wire from this board to this board, and very short wires. And that was my first idea how to do it. And it's not practical. It's very hard to do it. I mean, with the tools that I have, it's very, very hard. And I was thinking that well, I was having them laying down like this, exactly like I'm showing you here. And I was thinking, what if I will drag the wire that I want, solder it there, and drag it long to the end that I need, with them spread out like this. And even I can repair something, or I can even undo it and do it again, or put some other wires from this board on the back if needed. That's the compromise I will have to make, meaning more material to use, meaning longer wires with more material to use. But the trade is that I will get what I want. I will get them back to back, and the longer wires will be bent like this between the two boards. Imagine like a book. If it's like this open, now it's closed, and then I'm opening it again, add more wires to the back as I need it, and then fold it again back to back, exactly as my intention is. Compromise I have to make is using very long wires. So I have some wire, but I don't want to be too wasteful. But this will solve the mystery, the problem, the challenge. This is a solution for the challenge that I put in my mind, and it will look very neat. This board, unfortunately, it will have on the surface a lot of wiring. I cannot escape from the wiring that it will have on the surface. But this board, probably only this wire will remain, but the rest will be getting into those holes and on its back. Pretty much it will look like a chip without anything. If you don't look too closely, you will see some wires soldered by its pin. Not looking with too much attention, it will look like a simple chip glued to this board on those pads, and that's it. It will look very mysterious. And it's an interesting idea, and I believe this will be the plan to proceed further. Of course, this is the stage that I am right now. I will have to add some pads there, the connection pads, because I will have to link some wires to those pads as well, the outputs, especially the outputs. The inputs will be here and here to this 2x2x2x2, and 4 gates, 4 columns of transistors. And hello again. I had some events related and not related to this board here. I didn't manage to do much in 2 days, unfortunately, but I was thinking very, 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 very hard on this subject, on some parts of the board. I didn't start to put the wires yet, because I'm extremely concerned about the pads. There are a lot of pads. There are 14 pads here, and 12 for the data, and plus and minus another 2, so in total 14. I tried this version that you are seeing right now. What I did, I have my bag of a lot of stuff here, and I'm having this scrapped boards. This blue one, I use it. It was having a little bit here, and I took it out, and I took a bit from it. But as you can see, of course I have these large ones, and I actually numbered them. You see some points with the black marker there, and they are fitting there as well. And that is a very good option, but I want to use these very fine ones as well, and this is an opportunity to use it. So as you can see, this board is having on both sides, and this pads that's having, and it's pretty thick. It's 1.72 millimeters in thickness here. I tried to cut it in half, but longitudinally through here, and I managed to do it actually. Here is the other half. I put it there to not lose them, and they are thin as fuck. Actually, these are more. No, these are the thin one. And yeah, believe me, it's cut. I managed to cut it, and I have here this kind of tool. I made myself a reminder here not to cut iron, only plastic, wood, everything that is soft, pretty much. And this material is soft, but it appears is not soft enough, because these are very, very bad. I have here in my garbage, I have one. It doesn't cut anymore. It is the tooth are rounded all over the place. And I changed the blade, and it still got started to round it. This material is quite hard for this blade, for this metallic blade. Unbelievable, unbelievable. And I had so much bad luck, and then I tried it with my cutter here, with this tool to cut it. Again, longitudinally like this, in the middle of it, and it's very, 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 very hard to do it. And with the cutter, I could only make a slight indent, but not really cut it because it was a very big possibility to cut myself. So I tried to avoid that. It was very, very dangerous to use the cutter. And then I made this contraption. Be aware, today is 25 is the day, 07 is the month, and 2023 is the year. So it's 25 in the middle of the summer in that year. And it was pouring my here where I live. It was super, super hot. It was 39 degrees Celsius. I used my lathe. You see that lathe there? And my sweat was pouring on my forehead, on my head, on my entire body, and I started to sink. And it's so hard to sink when it's in the middle of the summer, when it's super hot. When you move a little bit, you start to sweat like Niagara. And I took this screw and I made a hole through it, and on this other part as well with 2.5 drill. I have it here with this 2.5, this black one. And because of course I measured the axle, and the axle is 2.3. It's not 2.5, but I make it with 2.5, and I'm not sure if you can see it, but I put a shim there. It's barely visible. It's very tiny, you see, but it's long as the channel that I made as the hole is very long hole like that. And I put a shim, and then I press fit it. Of course, that shim the exit a little bit down, and now it's running like that, you know, instead of exactly on the center. But it's okay. It's okay. I mean, it is stable here in the top. And here I made the same hole diameter with 2.5, and the hole of this disc is 3 something. 3 millimeter and something, and one screw of metric 3 M3. It got there. I made the thread internally, and then I screw it with the M3 screw, scrapped M3 screw, and that's it. It is working. I actually use it. I hold it in my hand. I put this is for 12 volts. Says there 12 volts, but I use it with 5 volts, and it was very, very okay. And I actually cut this a little bit, but unfortunately because of the vibration, it's having a little bit of vibration, and it's cutting instead of this 1 millimeter that is having the thickness of the blade 1 millimeter, it's cutting a little bit more wider than 1 millimeter, and I didn't cut well in the sense the thickness was too great, and I tried it a little bit, and it started. Actually, let me show you. It started to eat the material too much. So this is from the test I did with the blade, and it started to eat from the side, which I wanted to preserve it, and yeah, it kind of damaged it, but it is still functionable. I can still use it if I really, really want it. So and then I come back to this blade. I changed the blade, this blade that is right now, and I continued cutting it. I tried with this big saw actually, but as you can see, this is having. You see that ondulation? It's like a waving, like a you see? It's like that. It's not straight. It's like a serpent. So it's having like this, like this is the blade, you know, and it's a little bit ondulated, and that is actually 1 millimeter here, but from peak to peak, it's actually 1 millimeter, but it still was too wide for the material that I was cutting, and of course I cannot cut straight, and I have to do, you know, numerous times like that, and yeah, well, it didn't work. It also cut too much from a material too close to the side that I want to preserve, and I wanted something very, very thin to cut with, and this blade is very straight and is not having that ondulation on the tooth, and it is actually 1 millimeter exactly in the middle, and I managed to cut it with a new blade, but it got with the tooth of the blade was they were starting they are already rounded for some reason. This is a very mild steel, probably is not treated in any way. It's just garbage. I mean, for wood most probably, but even in wood, if it's too thick wood or too strong wood, it will get rounded as well, which is very, very, very bad. And I plan to search some very thin blades that are more sturdier, like HSS, high-speed steel, hopefully, or something more resistant, more durable than this shit that I have. Lucky me, I have a ton of a bunch of replacements, but if I'm cutting one single piece and the blade is dead, it's garbage. And I have it for a very long time, actually, for more than 10 years, and I never use it. I use it on steel, and then I realized on steel or iron is not good at all, but it's not good even on this material, the plexiglass that is used. Unbelievable. So yeah, I had a series of events that are not quite related. Another problem that I had, very, very, very problematic, actually, a very, very bad luck I had with my lamp here, and my lamp was, let me close it and show you. You see, this is actually a mold that I made all around all these segments with the LEDs on them, and the black stuff that you see there is actually plastic, but before this was white plastic, which is actually, let me show you. So I use this PP, which I'm using it a lot actually, because it's extremely malleable, it's extremely fluid when I'm heating it up. It's extremely fluid and it's getting into a shape that I want very quickly. But I have another one guy, and it's this pet. This is from beer bottle. You know those beer bottle, those brown beer bottles. This is it, you see. And I cut it stains like this, and so this is pet number 1. And I used PP before. And that PP got scorched, literally got scorched, got extremely cracking. It cracked, but it held for quite a long time, I believe 1 or maybe 2 years, 1.5 years, something like that. But it started to crack. All these modules, they were hanging down like this. They were hanging down, and then I had to take this module out. Lucky me, I have a power connector I made here, and I unplugged it, and I took this module out without wiring, without the wiring problem. And then I took it out from these two screws, and I'll get inside it and clean it up from the remains. It remained only here and there, it remained, but the rest was cracked. It was having no molding whatsoever, and before it was full of molding. And now these days it just it got extremely scorched. It was like dust, or like you know, very crackable, very but it got like that in time. So it's kind of good. It's kind of good, you know. And now I put so that was PP, this number 5, and now I put PET. This PET material, plastic. It's also plastic, but it's more resilient and it's harder to melt. A little bit more harder to melt with the same iron temperature, 300 degrees. And when it's melting, is extremely viscous, very hard to get into shape. I had to press it, literally to press it, to get into these little holes between the segments, between the modules. And then I had very thin wires. And now, as you can see, let me zoom in. You see, I put a bit more thicker wire to actually, even if it's the next time when it will be, I don't know, probably this plastic will also scorch and become dust, literally, and fall off. If the same thing will happen again, I hope not, but if it will do the same thing, at least this very thick wire will hold it in line and not bend like I had that problem before, the last time. So this was actually an experiment I did with that PP, with this PP material to actually to test it in time, how well will resist to, I'm not sure what temperature is this, I believe 100 degrees. Or 100 and something, 150 degrees Celsius. It's very hot when they are lit up, and especially right now in the middle of the summer, they are even hotter because ambient temperature is adding is not cooling it down, is actually heating it up more. So it's not a good idea to have electronics that are heating up now in the middle of the summer because they will exaggerately heat up pretty much. So I had to remold, reshape it, and make it again and put it back and fit it again. Only I know how I made it there, but I made it, and it was a challenge because I had to respect this hole that I'm having here, this distance, and also the length. Here this white is actually paper and somewhere there it remained on the margin when I lift it up from the paper, I put it on the paper and I molded it there, and when I lift it up I had to get with the knife and take out the paper and leave this hole pretty much, and then I mounted it into the plastic case that you are seeing here. Also I noticed here from the previous when it was bending, it bent like that until here, and I spotted this motherfucker, this yellow shit is from heating up, is from that thing that bent up like that, and it was very close to the plastic, and it started to burn it. And when I seen that, that told me it's a big problem, and I had to resolve it. I also made a note here for myself, the date when I repaired it. So repaired the plastic repairment is all that I did. That's what it says there. So these were some unfortunate problems that I had while doing this module. and even if I resolved this problem with so back to the original problem. So even if I resolve this very hard cutting problem that I had there, I don't like it. It's too close together. It's a chance to make shorts very easily, and I'm thinking to other ways of making these connections. Right now I'm staying and thinking on these problems because this is a very hard problem to resolve, and if I'm resolving it, if I'm dealing with it right now, the next step is only wiring, is dumb work, is work for dumb people. I'm doing it mechanically after that, not thinking at all. But this is thinking, and it's very hard, it's not easy. So right now, as you can see, I have a little update, a very small one. I put a piece of material here, you see, it's black on black, and you cannot really see it. Yeah, now you can see it better. You see, it's a blue, very dark blue. This is black, without color in it, and it's a piece of material. This is the piece of material that I use. I took this is from a shirt that got very damaged, and I had some pieces of material from it, and it's very good material, especially for you know, it's very thin, it's very good, and I use that, and I glue it with my glue for shoes. It's very good, and I glue it there, and I made like that, you know, like a hinge, and it's hinging, and it's remaining there. And when I'm doing this, you see it's staying because it's remaining. You see, it's not bending down. Only this way is bending as I wanted. And next, I will drag the wires from there to there, and then bend it back to back, and problem solved. And then I will put here the same as I'm having here. Here I will put a hinge made from this material, you know, as well, and I will glue the next board that will be on top. So this will fold like this, and the user interface pretty much it will fold like this here, you know, like that. And it's a foldable design. I didn't think of it in the very beginning when I started to make it. I was thinking only on these modules how to make them, but this foldable modality it came on the way. I was thinking how to link them and how to wire them, and to be easy, not only to wire them, but if I want to repair it, if I want to intervene after I made it, if I want to upgrade it, it's very nice to unfold it and look back on the traces and check them if they are making shorts, or if they are. So that's very important to have a way of debugging and checking it for errors or for shorts or whatever, for damages, and it's imperative. At least for me it is, and I am very happy with this design. It's a bit expensive because I will have to use very long wires. That's why it's a bit costly on the wires, but for the design itself, I'm really happy. I'm really happy with this foldable, and you know, pack, zack, and zack the other part. It will be gorgeous. I'm very happy with the design so far. Next, I will have to solve this motherfucker, which is a very big problem, for the moment. But I will find a solution. I will switch to these larger pads that I already have, or I will find something that I already actually thought on something. I thought to actually use very common wires with isolated common wires like this, and I'm not sure. These are bendable wires. If you bend it, it will remain bended. No, bendable it's called bendable wires. But they are strand wires that if you bend them, they will get back to the preview mode. And those wires I want probably it's best to use than this bendable wire. These bendable wires are prone to crack more easily and more fast. And but I'm not sure. But it's an idea. They actually use a very small space in the long space that I have in here. I only have to poke to make a hole and to introduce that wire, and that's it. Or two holes to make a strengthening, to strengthen the link that I have there. But other than that, it's eating very small space. Comparative with these guys, which are eating very wide, very long. It's limit to limit. I can barely fit it. I can fit it, but it's on the limit. And I have these two variants with either these guys or the other guys. I don't know. I wished I could be able to cut, because these are also double-sided, as you can see. They're double-sided, and I wish to be able to cut it longitudinally like that, like I tried today, and I didn't fail it. Even if it's looking like shit, it's looking horrible. But I don't care if it's looking horrible. I care that that if it's usable, and it is usable. And I wish I could be able to cut it longitudinally with a very, very thin and very strong material for cutting. So far, I had some insuccess, but well, in some respect, I have some success actually. Okay, thank you very much for watching, and see you later to the next update. Bye bye. And another interesting point is that people have the impression, very, very wrong impression, very unrealistic impression that guys like me are making money on YouTube. It's totally untrue and totally false. I never got money from anywhere, from YouTube or other sources. I'm making this stuff that I'm making with my own money and with my own time, and it's only on me. It's because I want to make it, and nobody is telling me to do shit. And all this stuff that you are seeing on my channel are designs for myself, made by myself, by my mind, by my desire of things that I want to make, and the help that I'm getting from you probably hear me mentioning an American that helped me, or an Englishman that helped me. Yes, they helped me, but the design and the idea was mine, and they follow along, they follow on the track, and they help me along the project. We like to do this stuff pretty much, and they are experts enough, they are good enough, way better than I am, and they are more knowledgeable because they did this stuff all their life, and whatever job they had. But they helped along the project that I was coming. It's good to have good friends. But beside this point is that I'm not making any money from anything that I'm doing here. I never made any money. I believe it's called content creator. And that's, I don't know what that means. It can mean anything. It can mean absolutely, if someone is farting and is posting that fart on YouTube, that is also content creation, and is garbage, is nothing. And you know, it's a bullshit, you know, and people are believing bullshit stuff like that. And but in reality, the real people like me, and probably others like me, are not getting anything from anyone. Those guys that are getting money, most probably they have a job, and they are sponsored directly or indirectly, without their knowledge probably, from the job company that they work to, or the government. I have no idea, but they are sustained there, and they are helped with or without their knowledge. And it's my best bet. And but the guys, simple guys like me, they don't get anything. So that's what I want to say about money and stuff, because it's important to know the truth, at least my side of truth. Not everybody's. I'm not saying it's the same for everybody, and I'm only saying this is the thing, how the things works for me. And yeah, I hope you like my stuff. all right. I believe this will be it. I just finished preparing these two pieces. I had a very long one here. I cut it. Actually, I didn't cut it. I used my saw, but I put a lot of work on filing. I used this file, very coarse, very rough file, and I file it like this, and I lower it down. It was I don't know, 2 or 3 millimeter, so it was like until here. Quite a lot I had to take out. It was too large. Why? And why I had to file it? Because I didn't have too much space, too much room from this end, where these are terminating here, to the margin here, and I can push it a little bit more like that, probably. Yeah, to leave a little bit more room, you see, between here and here. And yeah, I think, and they are 14, exactly how many I need, exactly. I didn't leave any spaces. So you see this point here, it's number 5, and this point here is also number 5. So 5, 10, and another 4, 14, and the same here. The same is here. 5, 5, 10, and 4, 14. And this will be on the other board that will be on the top here. I decided, as you can see, they are double-faced, and I cannot reliably cut them in half longitudinally. It's I don't have the tools to do it, and it's a pity that I will have to use the entire board back and face, and very thick, I may add, it's thick as this board with the transistor on it. It's kind of on the same level. And when I will add the wire here, it will be even thicker. And it's not ideal, but I like the spacing. It's that's the only reason I chose it after all. And I like the gap here. I have good gap, very visible, very. I can see if a short will happen over this distance. On the other board, the space was so thin, so small between the conductive pads. It was almost invisible to see when something will jump from one pad to another. So that's a very important consideration. And I don't have that many pads like this. You know, I have to find a way to collect more in the future, of course. I don't know, but I'm using what I'm having at this point, and it's looking nice. It's looking very, very sturdy. And if I will have to repair it, I probably was having to repair it with the smaller ones more than often. But instead, now I believe I will not have so many problems as if I was using those small ones. I believe this will not give me as many problems. So I'm kind of thinking ahead right now. And this is a decision what to use and how to use it. These pads, I stayed on this problem 2 days, literally 2 days, and I tried everything. And it was a costly thing. It was a problem. It was a very big problem. And it still is. It still is. Another version, I was discussing with my father. I was asking him for ideas, but he couldn't give me anything that I didn't think of. He gave me some very bad ideas actually, to cut only one like this, and no fucking way, and glue it. And but I had 3 ideas. The first idea was the seam piece that I already glued it there, and I unglued it there from there. And the second idea is this idea, what I'm having right now, with the larger, better pads. And the third idea is to actually make it from pieces of material and make all these tracks, all these pads manually, and fill up this entire length. And that was some work. And by saving these pads, I'm kind of cheating that work that I usually was doing on some projects before. That's why I keep this in this idea that I will need them someday, and I will escape with not doing it manually. So these are the 3 ideas I had, and yeah, this looks promising. We will see when I will actually build it out, when it will be finished, and I will say what I think after that. So to be clear, the decision that I took it cost me 2 days, not the actual doing. You know, well, that also took me some. It was stressful to create that one, to cut it, but the idea cost me. I had to decide. And after I'm happy with the decision, like I am right now I am happy with the decision, and I think yes, it is a go with what I'm having here. It is good enough. Before this version wasn't good enough. It was not good enough. It was under good, very low. No way. So I wasn't happy with the decision the first one that I took. So the decision, the thinking cost me about 2 days, 1 or 2 days, 1 day and a half, something like that. Right? All right. I hope now it's more clear. Yeah, I just glue it right now with my glue, and it's there. It's staying put. It's not hardened yet, so I have to. I'm just showing that it's already glued. But I find another version, another way of doing it, using these pins. They have, and I have a ton of them. I believe probably 1,000. I don't know. But check this out. The pins match exactly this pad configuration, this pad's spacings. That's one thing. And another thing is, if I was thinking to use them by themselves, but the problem is how to make them not move, to actually how to glue them there, because plastic doesn't work with glue. Glue will not adhere to plastic, and it will always snap from the glue, the plastic. So one way was to sew it with threading saw, you know, and then the length of the pin was too much. It's too big. You see, it's way too much. It's very close to the resistors there. So I thought another idea was to actually cut somewhere here and leave a little bit, pretty much. Yeah, this is magnetic. So to cut it somewhere there, and to leave as much as is here, to leave it here, something like that. And I will have a smaller dimension. But another problem arrived. This is very thick, very thick. It's way more thicker than this pad. And when I will close together those two, the lid that will come next, this very high element, it's unnecessarily high. You know, when 2 of them are stepping one on top of the other, it will be unnecessarily high. And one way is to move it aside, the other part that will come on top of this, so it will step on the pins themselves, or here on the other side. It's a little bit of a spacing problem what I'm having here. You see, so if the other thing will stay on the pins a little bit, move ahead. It's a bit problematic, but is an interesting alternative. Is a very interesting alternative by itself without this. So in the place of this, it's an idea, you know. And I will not use it now, but is an idea. And you can agree that this is looking way more professional this way than with any other thing, this or the other stuff. This is looking nicer. Very cool. I like it more. All right. Nothing here, right? But voila, I'm starting to put the wiring. This is the positive wire that is going from there. It's a hole There are multiple holes actually, but it's somewhere there. The hole, you see, here, and it's going to this rail that is underneath everything, and the negative is coming through here and going there, as you can see, that little link. And two inputs, these two inputs are going to this collector. This longer side is the collector, and one wire and another wire here, as you can see it there and there. It's a small little hole, and the wire is coming to the hole. Like I said, this is a little bit of expensive regarding the material. The length of the wires, it's a bit too expensive for my taste, but it's a practical solution. It is a practical solution, and it's also a very I discovered just now, this very interesting way of working like that, having it on the same side but linking it also on the same side, and I only have to bend them in the end. Everything will get bent. I put here a piece of paper because this is a positive rail, and I really don't want to short with some other inputs. Yeah, it's direct 5 volts to the input, and I don't like to have surprises. And I even put my nail there and make sure it's visible through the paper. And yeah, it's looking interesting so far. I'm quite pleased, and it's starting to get stiffer right now, but it will be bent in the end and unbent if I feel needed. But being copper, it's best not to bend it and unbend it too many times because it will break quite easily. So I want to show you a little bit of my process, how I'm putting 2 wires here from the other 2 inputs here to these collectors here and there. I already made a hole with my needle. Yes, I made a hole here. See, and it's very holy. You see, I made the holes, I prepared it, and now I will show you how I'm putting the wires. All right, on from start to finish, and this is it. This is how I'm making. I am a little bit of luck because I'm using this wire compared with this wire. You see the difference? This is more yellow and this is more red. This red one is having more lacquer, more isolation on it probably, but it's very hard to desisolate it. But this is very easy to desisolate. As you can see, it's much more yellowish than this. And I can desisolate it simply using my heating iron. And we are starting. This is me measuring the length of wire that I need. Right, a lot of wiring is going underneath. Ta-da! I finished all the inputs, and yeah, all the collector here and here for 2 pins, and all 4 of them, or 8, all 4 gates, or 8 pins in total, and a lot of wiring. Ta-da! So it's looking, a bit more complicated now. The complication comes from wiring only, not the logic. The logic is quite simple, but the wiring is just mind-blowing. All right, this is the only hard part of my projects, and is the wiring. You have to deal with it. Yeah, and voila, I finished putting all the wires to this board from here to here. Voila, this is how it's looking on the other side. A ton of wires, a haystack of wires, and yeah, everything will be bended and put on the back, kept on the back. It's looking good. It's looking good. I'm very happy with the progress so far, and everything is moving according to the plan. All right, this is it. This is what I wanted to show you. The wiring on the back, how it's looking so far. All right, I'm still in the process of making it. I didn't finish this board yet, but it's very close to finish. I only have to link from this pin, from this resistor to this pin, to this tab, to this pad, and for each of them. But the rest of the wiring is already done. I also made a mistake. Originally I put a negative here and positive there, And after checking it, because I didn't make it as I planned in 3D, I make it like this on this side, open like this, and some logic got confused in the beginning, but at the very end I catch the mistake. I didn't probe anything, I didn't test anything. I only observed the negative and positive were wrong, and I link them. This is how it's looking so far on their back, and as you can see is a ton of wiring. This is called rat's nest. This is a true rat's nest. I even bent it once, and then I unbend it back because I couldn't work while it was bended. And I also had later I needed to have access to this pads that I'm having here. Remember, this thing is not communicating with this face, so these two faces are separated. And also in my original design, the probe space was here. You see these squares, those are the areas designated for the probes to be. But then after I built it the way I built it here, I decided to move the probes here on this 1, 2, 3, 4, and on this other side of the same board that I'm having here. I'm smartly using its back now. And yeah, it's not really a big of a deal. I actually did the test to see, after I spotted the negative and positive, that they were swapped and corrected. I put the positive and negative 5 volts, and I watched my ampere meter from my power supply there to see if it's getting a short somewhere. It will jump to 1 amp. Usually I set it to 1 amp to jump, not higher than 1 amp, and it didn't. It stayed at 50 milliamps. So 50 milliamps is still high, but keep in mind that I'm using a ton of transistors here and also resistors, and these gates are probably active, and yeah, probably that's also no LEDs, no LEDs. So probably for all of this, when it will work, it will be probably around 100 milliamps. Who knows? So this is the progress so far. Like I said, I only have to drag 1 wire from each. Well, 4 wires pretty much. These wires here, and it's almost done. At least these 2 boards. And now at this point, at this moment, I'm having this black. I just cut it and to shape, and I took a LED just to have an idea, and it is looking very nice on black. Actually, I really like it, and the contrast is very nice by itself. And when it will get lit up, it will look even nicer. And now I will have this. This will be the display with the LEDs and some writing per each LED probably, and the title here, the name of the device, and it will be something like this, and it will bend from like this from the top down, and that will go underneath, and pretty much this will be the box. By the way, the box, I believe I will have to make a box for it to protect it, most probably. I'm not sure, completely sure. Probably it will be good enough as it is with these boards. I'll have to think about it, but yeah, so far so good. I mean, it's a weird project. I can tell you this. It's a very weird project, and it's new to me, and it's my all this is my idea. Everything I built so far are my ideas. Few are others' ideas, and yeah, pretty much is all that I want to say. Let's hope the display will look good and feel good, and let's hope it will work in the end. I'm so tired. I'm seeing wires in front of my eyes. I concentrated all night. In one night I made all of this, and I had to concentrate a ton, and also look back on my screen to check the wiring. Also worked with my diagram here in the same time. I had to double check it. A lot of work, and some wiring I did them mechanically without thinking, because it's just a repetition. And I hope I didn't make any mistakes. I already made that mistake with positive and negative main wires, but then I catch it and correct it. I hope I'm not having other signal mistakes, the links, because it is a nest, rat's nest here. Holy fucking shit. My father, I showed this to my father, and he said he made a cross, and he said, holy fuck, what you have there, you're crazy. And yeah, but he is very he doesn't understand shit from what I'm doing, my father, but he is amazed when it's working. Now when he's seeing it like this and all this work, he understands is a lot of work, but really doesn't appeal to him at all. It doesn't. For him, it's just like a piece of garbage or something. It's something without any meaning or value or anything. But when in the moment he will see it working, he will say, "Wow, that's cool. That's good." Well, he is not actually into electronics as much as I am, but being his son, probably he's saying it like that, to encourage me or something. I don't know. We will see. I'm very curious if this whole contraption that I'm making here, this project, will actually work in the very end. I put a ton of work, a ton of effort, and quite some time, and I concentrated a lot. It is deviously simple, Of course, the biggest problem was the wiring, the biggest, and I still didn't escape from. I still have to make the display. Holy fucking shit! It's hard. It's fucking super hard. Super hard. Thank you for watching. I hope you like my update for now, and see you later. Alright, I didn't film anything until now at this stage, but this is the progress. I made a user interface or the display. This is actually the display of the entire device. It will be like this on top of it. No. And I only put the first group of LEDs, this. I'm not sure if you can actually see there, but I actually write with black on black, and because this is graphite, is shining and is looking like a gray on black, but it's actually black on black. So you see, all these numbers are written with black graphite. So I put 1F0 and here as well 1F0, 1F0, 1F0 for everything. And I made I only link this wires to this first group of LEDs, and now I want to test it, and I didn't actually test it, and I will do it live. If you wonder what is this is for my wire to desisolating it, for desisolation the tip of the wires when I'm linking them there. But first I want to make a test to put wires on these three pads, then link them to these three pads, power it up, and test only this part for now. But I'm thinking to test all the sides because it's good to test things and to know if something is broken. I hope it's not. I hope everything is alright. And now is the moment of truth. And I worked very, very hard until this point. It's a very hard project. Definitely have a problem. I'm definitely having a problem. Shit, fuck. I have to figure out what is the problem. I have to say, where is the problem? Probably something broke up. Nothing. I have to put on the wire. Shit. Alright, I found the problem. And the problem was, can you see it? You can see it. I have to connect these lines, and I connect them, and I was expecting to work just like that, but I forget completely that I have another two lines, the positive and the negative, for all the rails that I'm having there. So that was the problem. And I actually started to check with the continuity meter. I was starting to check the pins and to the connections to these boards, and and then it crossed my mind, let's check from here to there, and I didn't have a signal, and not a negative and not on a positive either, so it was definitely a break somewhere. And the break was that I forget to add these wires. Let's see. And I'm showing you all of this because expect to make stupid mistakes like I am. I am making stupid mistakes. It's no problem. It's no problem. The important thing is to find the problem and to repair it. That's the only good thing you can. The only mentality. The only good mentality you can have. So find the problem, repair it, and move on, and solve the problem. Yeah. It is looking very, very ugly right now. I know, I'm aware, especially with these crap wires that I'm adding all over the place. And this wire got loose, then because I can see it. Yep, there we go. It's good to look. Yeah, this circuit is prone to many failures because it's having so many interruptions, so many links, and it's not ideal. I like small circuits. I don't like big circuits, to be honest. But big circuits are more interesting. They give interesting results, more cool results they're giving. All right. Let's see now how everything is going. I could add this wire somewhere else, not here. Please work. Please. Yes, the red light. All right, the red light. And that little guy. What the fuck are you doing there? You shouldn't lit up. Okay, so when I'm probing, negative, positive is working, but the negative not. Yeah, it's clearly I have an error there. Motherfucker. I have to find it. Shit, but it's starting to lit up, which is good. Okay. Yeah, I tested again, and I have another error. So what I did, I moved. I took all these three wires from here and jumped them here, but
I didn't desolder this. I leave them there. So I only moved here to this column, and here I have other set of errors. So definitely something bad here. I'm not sure yet what. I have no idea actually. And I checked everything with my needle, if the connections are made with my tweezer. There is no cracks that I'm thinking on cracks. You know, those very fine cracks that you. I don't know at this point. But definitely it is an error, and it's not good at all. Shit. I hope I can solve the problem. So to those who don't know what it should do, it only at this point should only lit when the probe, this wire, this yellow wire, when this yellow wire is in air, this red LED should lit up. You see? But they are lighting up all of them. And this one here, the yellow one, should lit up only when I'm touching to the positive here, or here. And the cold white one should lit up only when it's touching the negative. Definitely it is a short, a big short somewhere. But my ampere meter from my power supply there, you see, there is showing 50 milliamps, which is good. It's not that kind of short between the rails. It's a kind of short between the logic somewhere. I have no idea, but it shouldn't show this result, this output. It should only show the red ones. Yeah, we will see. I hope I can solve the problem and I can find the issue. All right, I finished all the LEDs connections, despite some stuff is not working yet. But I continued. I don't give up. I will find the problem. I will find it. So each LED is connected to this its respective pads. And on the back, this is how it's looking. Pretty cool. I like it. Very clean. It's good enough. And now all that remains, literally all that remains, is the connection from this board to this board. And the thing is done. Like that. Something like that. I'm thinking to add some protection, a paper here, glued all over these wires, just to be careful. I'm not sure if it's absolutely necessary. I think it's good enough. Here it will be the connections, possible connections between these pads and these wires. But other than that, nah, I believe a little bit of paper here, extended to here. We'll see. So I will have to make the connections, the wires. Woo, it's almost done. I'm very happy that I made it so far. I'm very happy. Even if it's not working correctly yet, but it will work correctly. All right. Just wanted to show you this wire that I'm having, connection wire, that I took it from here. You see? I took it from this side here. And this is a scrap data cable. And yeah, I have 14, I numbered them. I put a sign there for 5, and 4. And I split it like this to actually fit like that there. And also this side as well. And we will see. But it's looking interesting. Like that. It's looking aliens. It's looking like a piece of alien technology. Flux core linker. The flux core link boost converter. Doesn't it look beautiful? It is like it is from there, like it is designed by some brand like Sony or Panasonic. Yeah, it's good. I like it. Good stuff. So I put a mirror there to actually see what is going on the display itself, and voila. It's looking gorgeously, absolutely gorgeously. I love it. And on this part as well. You see, super cool. I love it. And it is looking cool in the mirror as well. My mirror is not dirty. This things that is having on it, it's from the other side, and it's a double mirror. You see, it's a double mirror that is. You can see my boldness there. It's a double mirror, and it's having this weird patterns under. It's a very old double mirror. So don't ask me from what time it is. It's made before my time, and it's having some sort of weird patterns. Right now I just clean it, and it's from the other side. So it's not this side. All right. So I put a mirror there just to see the shit. Probably a very good thing that I put all these wires here, the connections between these two modules, this band wire cable. Because all of them, except the first one, for some reason, the first one is not the same as the others, but it gives me a hint. It gives me a clear hint. Something is definitely not good. And I totally forget. And when I looked closely, with more attention, I totally forget to add this resistor between these two pads. Where it is. So that's the essential resistor. I totally forget it. This 3 kilo between the base and emitter. But in this case here, I have to use a 2.2, not 3 kilo. So there it is. Oh, this very important resistor. I totally forget to add it everywhere. So I didn't put it anywhere. And yeah, that's the problem. And it's almost ready. It's almost ready and almost done. Do you like my wiring here? It's very nice, huh? Let me zoom in. Very cool. Voila, voila. Yeah, this project was very challenging, extremely challenging. But I hope it's worth it. And I put the 2.2 kilo here and here, but here everywhere else you can see is not this in the middle here resistor. It's not anywhere on those 6 others. And voila, it's only one guy. excellent, it's working fine now. That was the problem. And now I remember while I was soldering this too, that when I took out the 10 kilo resistor, the 1 kilo resistor, I didn't want to mix them, to make a mistake by mixing them, and I took only the 10 kilo and soldered them on their respective pads on its collectors, and then I took another series of 10 kilo and linked them on their base here, base 10 kilo, and then 1 kilo here on the also on the collector, and I did it gradually, and I totally forget. And I know I remember that I leave for the last part. That was in my mind, to leave it as the last resistor value to add it, and then I got mixed. I got mixed with the wires to link the wires. I was putting myself problems with this board, with the wires and everything else, and it totally erased from my memory that I had to add this last resistor there. But all is fine now. Whew. So in the end, stupid mistakes are mainly from your side. Remember that. You have made some stupid mistake somewhere, and you have to track back, to step back whatever you did, and look more closely, with more attention. If you see something, maybe you can see something not at its place, as it shouldn't be, and that's how I did it. At least I looked more closely, and yeah, I remember the circuit. Actually, I was tracking the circuit. I was looking on the circuit here, and I was tracking it, but I didn't see it here on the circuit. I remember it by looking, and I remember, hey, it shouldn't be there. A resistor, and then I got back to my 3D version of the circuit, and yeah, it's a fucking resistor there. Fucking hell, I totally forget it. So that's it. That's the repairment. That's the problem. That was the problem. And I will put the rest of them on. It's practically finished. And I will have to add the probe wires themselves as well and make some tests. And I'm sure this is I'm sure it will be a very good circuit and a very good tool to use. Most probably this tool that I'm making right now, this device that I'm making right now, it will be used only once, and probably that's it. I want to use it for the stepper motor to actually see when the data is coming and what kind of data. If it's floating, if it's 1 or 0, that's it. On each 4 wires of the motor. That's why I made this design. That's why I thought on this particular device. That's why I envisioned it. That's why I invented it, because it is my invention to this point. It's a very cute invention, I suppose, I guess. Yeah, and totally awesome. All right, see you next time when I will put all the resistors, and hopefully everything will work as it should be. All right. See you later. And probably this is for the best to actually test everything, as it is not working right now on those two, but it is working right now on those two, on the first two. And it's probably a good thing to actually kind of calibrate it, see it working from a stage that is not working. And I didn't initially wanted to show you how I'm soldering some fucking resistors there, but I said, well, they are the last two, and this is finishing the project pretty much by adding those resistors there, and that's it. This is it, project finished. And well, I will have to add the probe wires after that, but it's almost project finished, 99% right now. No, well, 97%. So I will film it, and I will show you how I'm doing stuff. So I will disconnect the motherfucker. I'm not. So sometimes I'm soldering while under power, but right now I don't want to be. I don't want to risk it. So, and I had an incident. I put my hand here on this very. It was like a pool of, it was already solidified. It wasn't liquid like it is right now. But I put my skin, I put it there while I was concentrated there, and I totally squish it like that. So bad. It hurt a little bit. But yeah, stupid mistakes, right? Stupid mistakes. So don't do them. Actually, it should be good to have a proper position like that instead of here in my hand. And so this is already prepared. I already prepared it, and right now is it's just a matter of placing it. And excellent. All right, let's see it now. Everything is all right. It's working, motherfucker. It's working. Oh yeah. Now I will have to add the probe wires. Hold on 1 second. All right. Well, I just finished soldering this probe wires, and here I have negative and positive. I know it's not. I don't see well either. So this is negative, the last one, and this is positive, and this should be positive. This should be negative, and it's not. Fucker. What the fuck? Yeah, I remember that one didn't lit up the last time. Okay. Yeah, well, that's one bastard there. And this one should be, yep, negative. This should be positive. Excellent. Good. And So now I'm testing the probes directly on itself because it's easy. It's 5 volts, and it's what it should be. Positive. That is negative. Okay, good. It's actually very responsive, and I like it. Yep, good. So a little bit of problem for the negative there, the negative one. I will have to check it out and resolve the problem. But so far so good. So far I'm very happy with the design, how it's looking, and how it's feeling. It's yes. I can't wait to actually put it to work. And another thing is, so 5 volts with 20 milliamps. So all of this is consuming 20 milliamps. Probably 5 milliamps per LED or less. 3 milliamps per LED, and the rest of the circuit, who knows? Yeah, it's pretty good. I like it. All right. And I took out the transistor, and look what I find there. Do you see it? Do you see that link there? Come on, focus. It's not focusing correctly. Yep. Good, excellent. There it is. It's a fucking link between these two pads. A very tiny wire, is it? And yeah, that's the problem. Unfortunately, I used my needle here, my trusty needle. And while I was desoldering, I was pushing from this side. And when finally all the soldering points give up, the pushing was so hard that the transistor just flew away in my room somewhere there. So I will have to use another transistor. Damn it. Yeah, well, but at least I find the motherfucker. There it is. It's a tiny link, tiny wire that is crossing the two pads. Motherfucker. A lot of problems. Only for this side. I made a longer probe here. So I changed the PNP here, the NPN transistor as well here. I just changed it right now. I changed 2 resistors of 10 kilo. Here they are. They both had some the pad was peeled off, and I remember I did that a couple of times, but it still worked with that. It is still not working, even if I'm having here absolutely brand new components back in their places. And what I did, I took out all the wires from the pins, 2 inputs and 1 output with the resistor, and I dragged the wires, as you can see, this yellow, blue, and white, to another gate, pretty much there. And also I took out the output and from that respective gate. And when I'm probing here on 1, is lighting the 1. For some reason, is lighting this one as well. But when I'm probing the 0, is not doing anything, and it still is absolutely weird as fuck. My best. So I changed the transistors, I changed the gate, and it's still doing the same thing. Not lighting up this last LED. Unbelievable. I will put back everything as it was, because with this arrangement that I did just now with these wires, I pretty much used another gate. So this gate is okay theoretically. It's not the fault of the gate, as I originally thought. I was thinking to change the chip, to take it out and put another one, but I don't think it is the chip itself. It's some weird wire or some weird, I don't know, short somewhere. I have no idea how to make it work. Unbelievable. So this is how I'm tracing it back. I connected the negative rail, and I put 1 kilo resistor here on the positive, and I took out the 0 wire that was linked there on the pad. So on the pad is not this wire lit up, and when I'm touching the probe with the wire that is going to my LED, to my positive LED here, you see? So the wire is good, and the LED is not inversed. It wasn't. So this wire from here to here is good. Okay, good. Next, I will solder it back, and I will solder from the other side, and I will trace it back step by step. And hopefully I will find the motherfucker. Noticeable, very noticeable, is when I'm touching right now. Now I solder it. What the fuck? Seriously? So now it came back. When I soldered back the wire here, it started to behave normally. Unbelievable. So this pad or this wire is something weird here, and as you can see, it's not fully lit, because it should be brighter than this. It's some sort of resistance somewhere here, some sort of weird shit. Very weird. Okay, and now it's off again. For some reason, I just desoldered it and soldered it again and got off. Unfucking believable. Yeah, sci-fi. So one noticeable thing is when I'm powering positive now on the same layer, it's lighting up, but before it wasn't. What the fuck is going on here? Very weird. It wasn't lighting up when I was touching it. Shit. So it's definitely a leak somewhere. So some sort of leakage. I have no idea. You see? Now I'm probing it again, and it's not lighting up. You see? So the negative is common. The positive, I'm having 1 kilo here, and when I'm probing it, nothing. And neither on the pad, on its respective pad here, nothing. It's weird as shit. It's either and there I get nothing. I literally get nothing. Yeah, well, that's because I'm not powering anything. So this is good. This the other side probably. Yeah, well, that's the logic probably there. But here, the other ones are working fine. And this motherfucker doesn't. And it's not the LED. It is something dubious as fuck. Very, very dubious. And sometimes it's working, sometimes it's not working, and it's weird. Usually it's not working. And I took out the wire. By the way, I can do this, I believe. No? Yeah. Anyway, fuck. Fucking hell. Oh, I measured the wire. This wire, maybe it was interrupted or something. The probe wire, the yellow wire, nothing. It's good, it's good. Oh, shit. Alright, I am speechless. I have no idea what is happening. So what I did here right now, I put a positive and negative to this board. It's a bit funky what I did. I put a 4030, a brand new one, and I power it with positive, with negative, and I put the inputs to the respective pins here, which I unsoldered them from the original chip that I'm having there. Also the output, as you can see from the resistor that is staying inclined like that, I put this white wire to the output from this chip, and I'm practically using a gate from a brand new chip, and it's still exactly the same behavior as it was until now. It shouldn't have lit this LED. It should have been staying off, and only that one should. So this one should stay on here. Unbelievable. I have no idea where the fuck is the problem. And exactly as before, if I'm putting on positive, I think, yes, it's number one is okay. When it's defaulting to floating, like right now, it's staying lit, that one, which is good. These two modes are good. But when I'm putting on negative here on zero, it's not doing anything. Sometimes it's shutting off that LED, that floating LED, sometimes it's remaining on like it is right now. It's a very, very, very weird, extremely weird behavior I have. And only on this side, only the first line. The other three are working absolutely perfectly. So right now I use an external gate from this chip. I power it everything from this rails, and I put there and everything. It's still pie. So pretty much I believe that gate, that gate from there is not affected. Is good enough, and unbelievable. I have no idea what my next drastic thing to try is to take out the entire module, all the modules that I'm having here, and reconstructing them. I have no idea how to proceed at this point. I checked every wire, I checked every link, every component. Nothing is bad. Everything is correctly wired and soldered and everything. Unbelievable. I have some mistake somewhere, but I failed to see it. I totally failed to see it. So this is the logic so far. If, for example, I'm not sure if you can actually see everything. Yeah, something like this probably. Okay, so if I'm shortening this and this, you see that LED is opening. If I'm shortening this part with that part, is that LED opening. If I'm doing this, is not lighting up. You see? And if I'm doing this, is not lighting up. It's only shutting down that LED. Okay, so here, if I'm doing this and this, that on, and this and this, that on. If I'm doing this and this, that on. You see, that is on. If I'm doing this and this, that is on. So I also checked all the wiring here, and it's not shortening to anything. And also on this side as well, this zero wire, I also tested it, and it's okay. Also, right now, it's having moments when I'm touching the ground, is shutting off all the LEDs. But now at this point, when I'm touching the ground, it's not shutting it off for some reason. It's beyond me. And but all this exercise that I just did, all this testing that I did, is telling me that it's something here in this area, around here, where I don't know. I changed this transistor with a brand new one. I changed this transistor with another brand new already. Then I changed the gate itself because I was highly suspecting the gate from the chip as being erroneous of some sort, and I used this chip instead. So everything is powered. Well, it's commanded from this chip now. This first gate, I mean, this first line. Fucking hell! So everything is reducing to this board. My guess is to take it out from there and somehow to rebuild it, but how? I have no idea. Point out, this is how it should be. This only this last LED should be lit. Like I'm showing you right now with this other gate that I'm having. You see that white LED, the last one should be lit instead of nothing like I'm having right now. Or sometimes the middle one, the red one as well, which is extremely. I have no idea how to make it, how to repair it. I don't see any problem. Unbelievable. All right, so I made some measurements on an absolutely empty board. I took out the transistor again. I took out its resistor, this resistor here, from here. So the transistor was here. So pretty much all these three pads are empty. They represent the pins of the transistor, the legs of the transistor. And I got some interesting values, interesting readings. And hold on. Yeah, like I said, some interesting readings. I hope you can see everything. Better? Yes. Okay, so I'm probing for shorting, and nothing is shorting out, absolutely nothing. But I get some readings, and then this two. So positive here, negative here, and like that. Then I move positive here, negative here, 0.7, and here nothing. Then I put positive here, negative here, look at that. And then I moved to 20 kilo, and I got quite some readings. So from let's see, so from base to collector, 10 kilo, from base to collector. This 10 kilo, which one? Why is 10 kilo from base to collector? I believe. So it's okay. Let me finish reading everything. So I get 10 kilo from actually yes, this one is the PNP. So 10 kilo from base, and it doesn't have this. So it doesn't have this thing. This resistor here doesn't have this transistor. So from here to base to collector 10 kilo. Somewhere I swear to God, I don't see it. I don't see it. Probably the thing is that I connected this wire to the negative. So this is connected to negative to here. So probably this is the 10 kilo that he's seeing from base to collector, but through here. Weird. Okay. Yeah, it's 10.88, so it's almost 11 plus this and this right now. And okay, and then I get 9 kilo here. Positive to emitter and to collector. Emitter, 10 kilo to emitter. I have no idea. So here is positive to collector through. So probably also through this guy. Probably or through this. Or through this. Okay, so yeah, very good. And then I have this and this 18 kilo. And I noticed something between positive and negative. I have the rails. I have 8 kilo. But that's because first of all, this wire is connected to the probe is connected to the negative, so the probe tip is connected to the negative wire here, and there are the others, and also the gates inside. So all these readings that I got are from multiple possibilities. The stuff that I'm getting, that I'm having already there. Probably I should disconnect that and take another reading because this is a bit confusing, and it is confusing in the first place for me in the first. So let's take a reading again. Let's see if it's doing the same thing. No connection because I disconnected this wire from the negative rail, so I have no reading here. That's good. Yeah, here to here. So from collector to emitter, we have 10 kilo, 9 kilo. It should be 10. So from collector to emitter, positive collector emitter. I think. No, that collector to emitter. Who the fuck? Probably through this. This is linked to something else. Also to this. Yeah, I have no idea. Let's see the rails. I still have 8 kilo between the rails. The power rails. Why do I have 8 kilo between the rails? Probably. I have no idea. Yeah, so I have 8 kilo between the positive and negative. Right. And from here to here 9 kilo. Also 9 kilo. Okay. From here to here, nothing. Good. So here I have nothing. And here I have nothing. Here. And here. Nothing. Oh, here. On this stuff. Okay, good. Let's go to continuity. Nothing. And I'm switching to nothing. Okay, good. This. Yeah, like I said, I have this 8 kilo here and here. So positive up, negative down. So collector to emitter here. And this and this is 1.8 kilo probably, or volts. This pad is connected directly, so this is the emitter is connected directly to the 5 volts here. The rail. So this is connected to positive. This pad is a little link there. But this one is not really connected, only to 1 kilo to the negative. This guy. To this guy, here. This is connected to the negative, this is connected directly to the positive. And this is connected to the negative rail to 1 kilo. Yeah, okay. So you see, if I'm changing the sense, positive here, is another story. Then from here to here, nothing, from here to here, nothing. Okay, why these two guys, collector and emitter? This is the collector, and this is the emitter. Which is, like I said, is connected to positive. 5 volts, and this is through 1 kilo, which is this guy here. And also to the gate. This is the wire. So the collector, here is the wire that is going there, probably to the second or the first one. I have no fucking idea what is going on. I did clean up a bit more rigorously right now all these channels. You see this line here and this little line here. I scrub it. I scrub it quite well with my knife and with my needle, with everything I got. And yeah, next time when I will put back the transistor, maybe some miracle will happen. Holy fuck! What a shitty error. My idea how to repair it is to actually change the entire module, to take it out from there and use another one, because this one, it might have something in it, something bad. It's my idea. I mean, I have no other idea what it could be. I don't know, I really don't know. So this game is called Where the Fuck I Am. This is the name of the game, Where the Fuck I Am. Where is the error located? Where is the error located? Here is working okay, here is not. Now it's staying lit up. It's not lighting down. I soldered it back and the resistor and the transistor there. If I'm doing this, yeah, and if I'm doing this, you see, it's kind of reacting to my shortening that I'm doing here. But I'm doing it here, the shortening between 2 kilo to 10 kilo. So it's 10 kilo between them, so it's kind of safe of shortening here. But if I'm shortening the negative rail, it is powering down. It is influencing something from the circuit. What? I have no idea. Probably the gate inside there or this other board, because they are interconnected and interrelated. So probably my best guess is to take out this transistor and scrub those rails there. Maybe there is a short that is influencing the other one. It's my best guess, because this guy, it's clean. It's clean like my eye. Shit, fuck! What the fucking error? What the fucking error? I have no idea where is the problem. Unbelievable. And it's morning now, by the way. So I took out this resistor here because I measured it, and in circuit I measured it across it, exactly like I'm measuring like this, you know, the pins. Let me actually put it here. So I measured it like this, and it's giving me 10 kilo here. But here in the circuit it gave me 0.9, which means 1 kilo, I believe, or 900 ohms, 1 kilo. but the rest of them are showing me exactly 9 kilo over the resistor. You see, directly over the resistor. Really? Yeah, probably I touched something. Yeah, so 9.9 for everything. And for everyone that is going, this is, I believe, collector 2. This is 0. This is number 0. But here it gives me 0.9 across it. So I will solder it back because it's doing some funky business. I have no idea where. So now it's soldered back. Just checking it. And now it's giving me, you see, 1 kilo, 0.9, 1 kilo. This time it gives me exactly 1 kilo. let me switch here. It's giving me exactly 1 kilo. It is doing something weird. Very, very weird. But in reality, it is 10 kilo, as I showed you. And here, the other ones are showing me 10 kilo. 792, 8, 8, 8. Also 8, 8. 792, 8 is good. 698, almost 7, 7. Yeah, it's a little 7. It's a little bit off. But here this is 0.99. Very weird. Why is giving me across it? It's giving me 1 kilo, while in reality it is 10 kilo. The fuck if I know. And it is, yeah, here. Maybe this. I was suspecting from the beginning the LED, but it is working. But maybe this is a funky LED. Maybe here's the problem. Who knows? Who knows? Maybe it is a problem LED. Let's see if it's working now. No, still shit. Unbelievable. Okay, I will change the LED because that's the last thing that I can think of. So I changed the LED. The other LED that was before it, I managed to destroy it. As you can see, a part of it is no more. You see? Half of it. And when I'm probing right now, it is lit correctly. It is doing the correct thing. And also here. But I noticed something. Only now I noticed it. When I tested the other ones, they are a tiny bit stronger, but not much. This is too dim. This is very dim. And I believe the 10 kilo that I put there is too high. So I must lower it down. So all this 10 kilo that I'm having here on the PNP side, I have to lower them down a little bit to make this a bit more stronger. Not with much. I didn't think of it at all. It might have been the resistor being too high for that particular LED. Probably it got too hot and it kind of damaged itself, who knows. But I kind of solved the problem unexpectedly, I may add. Very strange. Although I tested this and I have to check the other guy, this guy that I originally made it. I have to check it to see what values have I used here. 103. Yeah, 10 kilo. 10 kilo, you see? Yeah. I have to check it. I changed it already with a 6.8 kilo. Here it is, 6.8 kilo, and it's not quite bright. Actually, it was a little bit more brighter, probably more brighter than this one. I know in the camera it's not really showing the brightness that well, but I kind of shorted it a tiny little bit, like, and it got even dimmer right now. And most probably I might have shortened the other one that I had, and it got dimmer and dimmer until it didn't work at all. So now with 6.8 is not good. I will go down to 1 kilo. Right, now we are talking. I believe I solved the problem. Now is good enough. The brightness is good. It's not that bright, but it's bright good enough. And I compare it to the other one, and the other one is okay. This is a bit more brighter, probably a tiny bit than this one. But they are kind of at the same level. Okay, I believe my LED, so the conclusion was my LED was a little bit too sensitive. This type of LED that I'm having, it was a little bit too sensitive, most probably to the heat, that probably I heat it up too much there when I soldered it, and also the resistor was too big for it, and also I put too much, I mistakenly put to the power rail a couple of times, and it didn't burn out instantaneously, but definitely it lowered its intensity down as to create problems. By scrubbing these rails of the boards of the transistor, most probably helped a little bit. I also noticed here at this point I had a problem, and by soldering it again, you know, remember when I was having, sometimes was staying lit, sometimes was not staying lit while I was holding it on positive like this when I solder it like in this position, and here was the problem at this point between these two resistors pretty much, and probably this resistor was making some sort of connections or not. I'm not sure. Probably the this part peeled off or something. You know, sometimes it must be internal because externally I couldn't see anything. So most probably too much heat again. Very interesting, very interesting. But I find the problem and I find the solution, and I'm very extra mega happy. And I'm so sick of it. I'm so tired of it. I'm super tired because this last problem just was too much. I remember I had to link everything. Holy fucking shit! And I did way more work than when I filmed here. So what I filmed here is only a percentage of what I actually did in reality. In reality, I did so many things. Holy fuck! I'm so happy it's solved now. It's resolved now. Holy shit! I will change the others as well with 1 kilo. All right. Another probable cause might be the resistors themselves. They are both 10 kilo, as you can see. This is 10 and 30, so it means 10 kilo, and this means 100 and 20, and also 10 kilo. And these are the older batch that I had, and I use this kind of a resistor here in this you see 103 there, and also in the interior as well. This part here is the PNP part, and you can see it's 103 and 103 here, you see, and there is 800 something. It was almost 1 kilo. There is almost 1 kilo, but here is 103 and here 103. Okay, so I believe I might eat shit right now, but I believe there are differences in the quality of the resistor. I might eat shit. I might say something untrue. They might be the same thing, only the numbering is different, and that's it. And the technology might be the same for both of them. You can see there is a little bit of difference between them, actually. Tiny bit one, I believe. It's a little bit slimmer. I have the impression this guy is a bit slimmer than this one. This is a bit fatter, a bit fat comparative with this. So, but the idea is that these are the new batch of 10 kilo that I bought last time, and this is the older guys that I had all the time for a very long time, and I use them. And when this new batch came in, I mean, I work with them. I use them quite a lot, but only now I see I use them here. You see, for this output and for that particular LED, and which is this one, which I managed to fuck it up when I tried to take it out. I forced it too much and it got fucked up. It would be cool to work like this on a half. I don't think so. But yeah, back to this. Might be different quality of resistors. It might be. It was an idea. It was an idea of mine. All right. That's why it didn't work. That's why it caused me so much trouble because of the quality of the resistor. That's my idea. But I might eat shit. It might not be the case. But if it is, that's not good. Everything with 1 kilo, only on the PNP side. And when I'm probing, this is the first one. And it's okay-ish. It's like this one. See? It's kind of bright. But the other ones are super bright. All three of them are super bright. So I'll have to change this tree back to 10 kilo. Those three guys that are already take out. So I'll change this back to 10 kilo to be on the same intensity, because these three are just blinding. And this is very, dim enough, dim as that one. And shit. a ton of problems. Damn. All right. I know it's not perfect how I'm filming it, but it must do. So I changed back with 10 kilo, all these outputs only from the PNPs, and only this guy I left it with 1 kilo there, because he has a problem, a little bit of problem. And now he's getting... What the fuck is this shit? Ay caramba. I didn't do anything wrong. But most probably maybe I made another short and the LED give up. It might be, they might be that sensitive. But now when I'm testing for the positive, nothing, only the negative. And the negative here, only the positive. And the negative here is doing absolutely nothing. The positive is working, negative, yuck. Shit. It's the same story as before. I plan to change it because I learned my lesson already, and I plan to change the LED again. It might be a little bit burnt out. I know for sure it's not totally burned out, but it might be a little bit. It appears it's not the LED either. It tricked me. It's not the LED. For some strange reasons, it worked. Now I changed the LED with a brand new. I didn't stay too much. I took care with the soldering, and when I'm probing, nothing, only that one, and that's it. It's the same exact behavior as before changing it, while the others are working like no other business like that. No problem. Absolutely no problem. Unbelievable. Unfucking believable. And that's the one that I took it out. So I probe it with 1 kilo here. And it's working okay. Also on the pad here, also okay. I noticed something, although. So if I'm probing here, nothing. Okay. But if I'm doing, so nothing. So if I'm doing here, this, sometimes it worked correctly. Now it's not working correctly. It's even staying lit, that one, when I'm touching it, and it's not shutting off. It's very, very, very weird. I don't know what is going on. Truly, I am speechless. I am truly speechless. And also I made this thing, and sometimes it gave up and it started to work correctly, but no, I have absolutely no idea what is going on. What might be the problem? Unbelievable, unbelievable. And it worked for a little bit. Oh, yeah. It might be some weird current surging somewhere. Where exactly? The fuck if I know. I should revisit the circuit diagram and insert probably some diodes, protection diodes somewhere to avoid this type of misbehavior. Probably, I have no idea. It might need some protection with some diodes. It's my belief. Shit. And only this part is not working. The rest are just don't care. Unbelievable. The gate is fine. Incredible. Holy fucking shit. I believe I spent 1 day and a half, most probably. I slept one night, but before the night sleep, I worked probably 1 day or half a day, probably 12 hours or something, to resolve the problem, to discover the issue, and I couldn't find it. And as you can see right now, it's working absolutely gorgeously, as it should be, like the others. There, you see? And what I did, I checked everything, already. And what I decided in the very end, I changed some resistors here and there, and I discovered, actually these are the resistors, and I discovered, let me actually bring them here. I discovered some of them were a little bit damaged for whatever reasons. I'm not sure why. Most probably the overheating problem. Come on. Yeah, I wanted to show you them on their back here. So in the end, before I'm explaining the resistor problem, I actually, one or two, I took them out, I stressed them, and I took them out. And as you can see, there is no pad left. Down like that. So there is no pad. You see this, yeah, this is non-metallic. So, you see this shiny pad is having it here, but here on this other side is completely peeled off. The same is true here, is also peeled off, and also for this one as well. And but before, let me get back. So before changing anything, I changed 1 or 2, and I noticed that, and I put them aside. Only one I put it aside, or 2 maybe, but the other was good actually. The other was completely okay. So I put 2 aside, but 1 was good. 1 was damaged, and I observed that. And then I took some break. I watched some movies, And now when I was thinking on the problem, and I decided that I should take out the board. And actually, I get back to the problem here. I started to measure everything, and all the time, all the measuring that I did with on continuity meter. So on continuity, I got on the diode, pretty much on the diode, I got some numbers, and I checked every one. So I checked the rail and 1 pad. So on negative rail here and 1 pad, and I checked them for all of them, and I noticed the values. I even started to make a drawing here, what I checked. But this was, I didn't use it that much, but I was desperate like that. I was desperate to, and actually I started to make a drawing, but I didn't use it at all. It didn't help me that much. So all the measuring that I did for everything, in the very end, so I measured from the negative rail to each pad and from positive rail to each pad, and I did it for everything, for all the boards that I'm having here. And only in one single instance, I got a different value of the diode from this pad, which is the base, to these 2 rails. Doesn't matter which rail I use. So all the measuring that I did and the comparison, they were hinting me, they were pointing me that somewhere here is the problem, but it didn't actually tell me where exactly is the problem. And after measuring, making all the measuring, I decided that this is a hint, this is a marker, that this is the problem. So if this is the problem, I should take out the entire board. This is the old board that I took it out, and change it to the brand new, and I file it, I clean it very well with my files. I have some files there, very good ones with very sharp edges, and I clean everything, and I mounted back the same components that I had before, but not really the same. I took one or two new, but I used one or two used components like it was before, and I assembled, and I put 1 kilo there. I believe it was brand new, 1 kilo there. Or the 1 kilo that was before when I was testing. And when I tested it like this, it was working. It was working like it is working right now, but with the exception that this LED was a tiny little bit open. And when I was probing the positive here, or no, the negative here, when I was probing it, was lighting up like it is lighting right now. But when it is lighting right now. But when I took it out, it got off, but not quite. It was a tiny little bit on. So I decided to change that 1 kilo with a 10 kilo that it was previously before it, and I changed it there, and the same problem started, the same behavior appeared again. The same problem when I touched here, no LEDs were open, or the red LED was staying open all the time, indifferent when I was touching the negative rail here. So this was not opening at all, not lighting. So I decided it is a problem. I figured it out. I understood that it is a problem of resistors. So the problem was all the resistors that I'm having here. The 2.2 kilo, I don't think it was a problem. What I took out all this peripheral, all this side resistors, these 3 guys, I took them all out, and these are the 3 guys that I took them out, and I put instead of them absolutely brand new guys. And I also when I was having the problem like before, I was pressing with my needle point, I was pressing, and here at this point and here on this point I was starting to get some flickering. Finally, that was the biggest problem that I had. I didn't catch the flickering. When you catch a flickering, you know exactly where the problem is, but I didn't catch it until recently, until right now, a few moments ago, when I solved the problem. So I understood that if the resistors are the problem, I took them out, and they are. And when I look on their back, as you can see, as I showed already, they have partial or absolutely missing pads, and that's absolutely the main problem. The other problem is they were like this, all of them. That's the problem. I was thinking it's only one, but it was a cumulative problem. It was this one plus this one plus this one, and in total making a bigger problem. So a little problem here plus a little problem there plus another little problem here. They fucked up the circuit. They messed it up, and that's the problem. That was the problem. The real problem. So every resistor that I had there contributed to a bigger problem, a little bit, a tiny bit. And I'm not sure what is the actual cause. My main reason, I believe, is putting them down and taking them up and soldering them back again and desoldering them. So I'm soldering them and desoldering them a couple of times. That's the problem. I believe that's the reason that pad of the resistor peeled off. And also bending them. When you bend them, they peel off very quickly. If you push them when you want to take them out, that pad is taking off, and goodbye. Erroneous behavior, pretty much. That's the problem. Very erroneous behavior, and they introduce a lot of errors, and the circuit is not working properly or not working at all. And right now I have absolutely brand new resistors here and here. The side, these 3 guys, the 3 musketeers, and it is right now is working as it should be without any kind of problems, as the others are working. And I tested the others as well to be absolutely sure it is resolved. The problem is resolved, and it is. And I'm super happy that I figured out the problem. It's absolutely amazing, and I'm very happy right now that I figured it out. Holy fucking shit! I changed literally everything there. I changed everything, and from there as well. Crazy hard. But this is a lesson. And not only for me, for others as well. Thank you very much. I hope you like it, and see you next time when I will probably make a case for it. I will have to make a case and fold it and make it a device in itself. All right. See you later, and we'll see you the next time. Bye. From Romania, from our favorite artist, electronist, Mr. Kirill.